Let's take a look at question 14. Calculate the initial momentum of the carts. We have two identical carts moving 6 meters per second and they both stop. So how would we calculate the initial momentum of the carts? Good. Momentum, we would just simply go mass times velocity, and the cart is, both of them are 1.5 in both cases, in case 1 and case 2. And then they are both going 6 meters per second, so we would get 9 kilogram meters per second for A. Okay. Now, if they both came to a stop, what would be their momentum when they came to a stop? 0, right? So here's our before momentum, and then the after momentum is 0, because they came to a stop. So what would the change in momentum be?
Negative.
So if we did change in momentum, we would want to do final minus initial, which would be 0 minus 9, or negative 9 kilogram meters per second here for letter B. Okay. Now, which cart experienced the bigger change in momentum? Well, they both experienced the same change in momentum since they were going the same initial velocity and then the same final velocity. They both have the same initial momentum and the same final momentum. So they have the same change in momentum. So on this one, we would say both carts have the same momentum. Takes us to letter D. Which cart felt the bigger impulse? How would we figure out impulse? Remember, impulse is equal to change in momentum. What did we figure out their change in momentums were? Negative 9. So which cart felt the bigger impulse? Same. If they have the same change in momentum, they have to have the same impulse. Now, which cart felt the bigger force? You come back. You say cart 2 felt the bigger force. Why would cart 2 feel a bigger force?
Because the first one was green, so it kind of bounced back. But the second one hit a wall, so it just...
Well, neither of them are bouncing back. But if we look at your formula for impulse, okay, we need to look at that formula for impulse. It is force multiplied by time. So let's calculate the force on each cart using this formula. We can rearrange it, divide time on both sides, and we can calculate the force by taking the impulse and dividing by the time involved. So let's do that for the first cart. Let's do that for cart 1, and I'll do it right down here. So here we have cart 1, and we know the impulse. What was the impulse for cart 1? It was negative 9 kilogram meters per second. Okay. And what time did it take to stop? 0.5 seconds. So negative 9 divided by 0.5, or negative 9 divided by a half, would give us negative 18, and it's force, so it'd be newtons. All right, so now let's do cart 2. Same formula. What was the impulse on cart 2? Good, negative 9. It was exactly the same as cart 1. Okay, and that's what we've said. Same momentum, same change in momentum, same impulse. So we plug in negative 9 here. And how long did it take to stop? Oops. Come back here, 0.1. So negative 9 divided by 0.1 gives us negative negative 90. So if we look at these two carts, they had the same impulse, but they had very different forces. This one, cart 1, had a lot less force at negative 18 newtons, where cart 2 had a huge force put on it at negative 90 newtons, large average force. Well, why is that? If they have the same impulse, why does one experience such large forces when stopping? Because of the time. So this one had a large force, but a very small amount of time, whereas this one had a much smaller force, but a large amount of time. And when we multiply those two things, we get the same change in momentum or the same impulse. Okay. So let's look at that here.